Hello students, I am making this video especially for class 10th physics students who are seriously involved in their preparation for upcoming board exams. Through this video, I am going to help you to revise the electricity chapter in short time. Now start with first topic, which is electric charge. What is electric charge? It is a property of any object because of excess or deficiency of electrons on it. It is characterized in terms of polarity. There are two types of polarity, like we humans have gender, male or female. Charges have polarity, positive and negative. If any object have excess of electrons, then it is said to be negatively charged, and if an object have deficiency of electrons, then it is said to be positively charged. Now, these charged bodies or these bodies having excess or deficiency of electrons can exert attractive or repulsive force on each other depending upon polarity. If two bodies have same polarity of charges, then they will repel each other, and if both bodies have opposite polarity of charges, then they will attract each other. The symbol used to represent electric charge is capital Q. Sometimes we also write small q. Symbol used for charge is Coulomb, which is in short mentioned by capital C. Charge on one electron equals to 1.602 10 inverse 19 Coulomb, and polarity is minus. Charge on one proton is again same value, 1.602 10 inverse 19 Coulomb, and polarity of charge on proton is positive, and charge on neutron is 0, means neutron is electrically neutral particle. Now, what happens when these charges flow? When this charges flows, then the rate of flow of charge is known as electric current, which is indicated by capital I or small I with unit ampere. From formula, the another unit of current can also be Coulomb per second. Coulomb per second, or we can also write Coulomb second inverse. Now, during flow of these charges through conducting materials, atoms of conductors opposes the free flow of electrons or charges through them. This property to oppose the free flow of electrons or charges through the conductors by the atoms of conductors is termed as resistance of the conductor, which is indicated by symbol capital R. Its unit is ohm, whose symbol is like this. Now, we talk more about resistance. It depends on four things. First one is working temperature, at which temperature the wire is being used, circuit is being used. On material of conductor, of which material conductor is made of. Conductor means wire. We can use copper, silver, aluminium, etc. to make wires. Third one is length of wire, length of conductor. So it is seen that as length of conductor increases, resistance of conductor or wire also increases, and if length is decreases, then resistance also decreases. Hence, we conclude that resistance of any wire is directly proportional to its length. Now, the fourth factor on which resistance depends is cross-sectional area, or in simple words, thickness of wire. It is seen that if wire is thick, or if we increase the cross-sectional area of wire, its resistance decreases, and if we increase if we decrease cross-sectional area, then resistance of wire increases. It is just like traffic. If we have broadened roads, then we have least traffic, and if we have narrow roads, we have maximum traffic, maximum congestion in movement from one place to another. So here we conclude that the resistance of wire is inversely proportional to thickness or cross-sectional area of wire. Now we club these two properties as resistance proportional to ratio L by A. Here we now replace proportionality sign with equal to a term proportionality constant rho appears. Now the question is, what is rho? Rho is known as resistivity of material of conductor, and since it is a parameter associated to material of conductor, not wire, means copper, aluminium, silver, it depends only on two things. First one is working temperature, second one is material itself. It has no effect of length of conductor and cross-sectional area of conductor, and it is very important concept. Now we see the unit of resistivity. So using this formula we can write resistivity equals to R into A by L. So we have this, we can cut 1 meter, then we have ohm meter as unit of resistivity. Right? Now, next we move to topic combination of resistance. One thing is left, symbol. Symbol used to represent resistance is like this zigzag structure. If we have an arrow sign, then it is variable resistance, whose value can vary. Now we talk about series and parallel combination of resistance. In case of series combination, formula of equivalent resistance is simply addition of all resistors. If we have equal resistance, then in that case equivalent resistance is equals to number of resistance into magnitude of one resistance. So if value of one resistance is 5 ohm and if we have 100 such resistance which are connected in series, then equivalent resistance of this series combination is equals to 100 times of one resistance value, which is equals to 500 ohms. Right? Another important points to take into consider is when resistance are connected in series, the potential difference across different resistance are different, but current flowing through all resistance is same. Another combination is parallel combination, for which the formula is 1 by Rp equals to 1 by R1, 1 by R2, 1 by R3 and so on. And if we have identical resistance, then the value for equivalent resistance equals to R by N. Taking the same example, if these resistors are connected in parallel, then equivalent resistance can be equals to 5 by 100, because value of one resistance is 5 and their number is 100. So equivalent resistance is very small in parallel combination. Right? Now we have to focus our concentration on Now we have to keep in mind that what is difference between these two combinations. As discussed earlier, voltage drop across all resistance in case of series combination, voltage drop is different, but current flowing through all resistance is same. It is completely different in case of parallel. All resistance will draw different amount of current depending upon values of resistance, but the potential difference across all resistance will be same. It is used in our houses, offices, factories, industries, etc., where all devices are operating at 220 volts. So in parallel combination, all resistance will have same potential difference, but as per capacity of device or resistance of device, they will draw different amount of current, right? So we can also tabularize them: current and voltage in case of series, in case of parallel. So in case of series, current will be same. In case of parallel, current will be different. In case of series, voltage is different. In case of parallel, voltage is same. One more thing, for same numbers of resistance and same values of resistance, we have Rp much smaller than Rs. This is the second reason why we use parallel combination in our offices, home, industries, etc. Now, next, electrical power. What is electrical power? It is simply product of voltage supplied and current drawn, right? Its unit is watt. One important law we left, actually it is Ohm's law. What Ohm's law say? Ohm's law say that current flowing in conductor is directly proportional to voltage applied. We can also write it like this. Again, we replace proportionality symbol, and resistance R appears here as proportionality constant. From here we get two more formulas: R equals to V by I and I equals to V by R. Using these two values here, we can also have formulas for power as if we use V is equals to IR, then we have power is equals to IR into I square R, and if we use I is equals to V by R, then we have power is equals to V square by R. So we have three formulas for electrical power. Now, what happens if we multiply power by time? We will get electric energy. What is electric energy then? Electric energy is simply product of power and the time duration for which a device is used, and time we take in second. So we have power as VI, power as V square by R, and power as I square R. So VIT, V square by R T, I square R T. Right? So students, hope this video will help you a lot to revise the electricity chapter comfortably in short time. For any doubt if you have, you can text me on my WhatsApp number 9179979001. Okay students, best of luck. Bye bye.